beginning of the new phase, right? What phenomena it is going on, right? Suppose if you want to increase the radius of curvature, suppose if you want to decrease the diameter, right? Suppose if you want to change the mirror, what actual phenomena is going on, right? What actual phenomena is going on? Okay, all of those, see, this is an object, a virtual image is formed, convex mirror, what is a reflection, what is a refraction, how many types of images are formed, right? Okay, what is a real image, what is a virtual image, okay, how it acts like a real object, okay, lots of things we are going to discuss in today's lecture. Lots of things we are going to discuss in today's lecture. So basically, right, basically, suppose, okay, three types of rays, right, three types, through three types we can pass on the rays. Okay, first, these are the multiple options, we are going to discuss it later, right? We are going to discuss this later, because right now many students might be thinking, sir, what you are displaying, we are not even, right, capable, okay, to just have a thought what actually, right, things are moving on. Okay, so I think without wasting our time, again we will come back to the simulation, because the most important today we are going to discuss about the plane mirrors, right? Okay, plane mirrors, how object is formed, right? How image, not how object is, how image is formed, what is the nature of the image, the types of the object, the types of the images, right? Lots of things we are going to discuss. What happens when the mirrors are inclined, right? What happens when the rays deviated from the mirrors? Lots of things we are going to discuss. On basis of that, directly questions are coming up into an examination. So guys, it's time to move on, right? Hello bachcho, Sat Sri Akal and Namaste from my side. How are you all? This is your own physics educator Indrajit Singh, welcoming you all into the most sensible platform for an aspirants, those who are preparing for JEE NEET kind of, and we are expanding into the multiple horizons and we are enjoying a lot, right? We are enjoying a lot. So yeah, today we are going to start the new phase of the chapter, of the syllabus, sorry. It's a new chapter, ray optics. If I'm talking about the syllabus of the entire 12th, then this is designed in such a way. The front part is electrostatics and then comes current electricity. Till then, we are only dealing with the electric fields and their respective data. Now suddenly arrives magnetic field, the magnetism. First, we are going to deal with an external magnetic fields and how the particles reacts, right? Then we are going to discuss how the current carrying conductor produces the magnetic field and its variations and the respective mathematical expression. And then we moved on how the matter is showing the magnetism, right? How matter is showing the magnetism. So lots of things we have studied. So first, in the front part, we were having the electric field and then came the magnetic field, and then we move forward to the flux, the electromagnetic induction. Okay, till electromagnetic induction we were only having the DC supply. Okay, now the war between AC and DC starts. Yes, the same war that went on between the Tesla and the Edison. Okay, on the basis of that, lots of films are there and blah 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 blah. We are not moving on to the history. Everyone is aware of that part, right? Everyone is aware of that part. Now, after suddenly, right, completion of the the alternating current, here comes the combination of electrostatics and magnetism, that is electric field and magnetic field. Okay, it results to the electromagnetic waves. Okay, And after that, the new branch, that is optics, we are going to deal with the now into the 12th syllabus, we are only having the optics, the ray optics and the wave optics. Into the 12th syllabus, we are only having the ray optics and the wave optics. Okay. So, things are gonna be crazy. Things are gonna be awesome. Things are gonna be fine. Right? We have to deal with it. Okay. So, the ray optics would be it is divided into the 10 lectures. Okay. And after that, wave optics will come. It is divided into 5 to 6 lectures. And after that, small chit put. Right? These things are going to come like atom, nuclei, the semiconductors, dual nature. Okay. Semiconductor is a huge, but some part of it is discarded. But we are going to discuss the maximum syllabus of it. Okay. So now, what will be the agendas of the today's lecture? It will be ray optics. Okay. If I am talking about the ray optics, the branch that deals with the phenomena of light. Reflection, basically we are going to deal with the, you can say directly we are going to deal with the reflection and the refraction. But indirectly, lots of formulas, lots of mathematical expression, lots of logical concepts, lots of things are going to come. Okay, the total internal reflection is a different phenomena, but it is a part of the reflection. Okay, somewhere we are going to face where, see, first of all we are going to deal with the reflection, then we will move on to the refraction. Okay, after that the simultaneous things will come in which we are going to deal with the reflection and the refraction both. Okay, and then at the end we are going to deal with the optical instruments like microscopes and telescopes. Okay, so this is gonna be the very awesome part. This is gonna be very awesome part. Okay, so without wasting our time, let's begin this ray optics. Okay, basically, if I'm talking about the ray optics, okay, the two most important phenomena we are going to study. Two most important phenomena. See, the entire lecture, if I'm talking about, okay, the entire lecture will be based on the fundamentals. Tomorrow, we are going to start with the object in front of the plane mirror and its respective velocity. Day after tomorrow, we will come up to the mirror formula and then we will start the refraction. Right? Okay, so in the mirror formula also we are going to do lots of stuff you are going to enjoy. Okay, so basically if I am going to move forward on the classification of the ray optics, then we are having the reflection. Okay, and refraction. Reflection and refraction. Our agendas will be reflection into the today's lecture. Okay. Let's see how much part we are going to cover, how much part we are able to cover. Okay. Because lots of sums we are going to do and lots of visualizations, lots of simulations are going to come. So my request is to you all, stay till end. Definitely you are going to gain some knowledge. Despite of the classes being into the pure English mode, definitely you are going to gain some knowledge. Okay. So, the classification of the ray optics moves on to the reflection and the refraction. Now, if I am talking about the reflection, a very simple phenomena. If I want to define the reflection, okay. So, first of all, before moving on to the reflection, let me clarify one thing. Okay, from now onwards, we are considering the light as bunch of rays, right? N number of the rays are forming, right? They are forming a beam kind of thing that is known as light. So whenever we are going to deal with any concept, we are going to consider the light as a bunch of rays, and among them, we will take some rays to understand the concept fundamentally, and we are going to represent those things to the most appropriate manner, right? Okay, so what is a reflection? Okay, what is the reflection? First of all, the reflection, right, if I want to define simply, then refraction is a phenomenon related to light. Right? Reflection is the phenomenon related to the light. Who is involved? Three entities are involved. The first, object is involved, image is involved, and the surface, that is a responsible thing for the reflection, right? All are involved into the phenomena. It is important to understand the logic behind it, who is involved, because without understanding that who is involved or whether, right, how we are going to obtain and how we are going to grab the concept. Okay. So first of all, what is a reflection? It is a phenomena. We are going to study that phenomena through the multiple ways. Who is involved? The first one, object is involved. Second, image is involved. Third, the surface, right, as because of that the reflection is going on is involved. Now you all be having a thought, you all might be having a thought into the mind. Sir, object, first of all, you had a classification of the ray optics as a reflection and a refraction. Is it cool? Yes, is it cool? Now I want to tell you all, is it so for sure, right? Is it for sure the object and image might be having some kind of the classification, or the surfaces might be having some classification? We are going to discuss detail about the, in detail about the object, in detail about the images, in detail about the surfaces. The first about the surfaces, second about the images, and third about the objects. Right? So first, reflection is a phenomena of the light. Second, which entities are involved, how it happens. So if I'm talking about how see, one surface is there, right? On one side of the surface, we are having a medium. Medium is the thing in which light travels. Generally, if I'm taking example of a medium, then the vacuum is nothing else but the free space. But if I'm talking about the water, if I'm talking about the air, this all are the medium. And in entire ray optics, vacuum and air is considered as the same one. Right? Okay. There is a partition of the surface. From one side, ray travels into one medium, from one medium, and it comes back to the same medium. Ray travels from the one medium, okay, ray is traveling, it strikes on the surface and comes back to the same medium. This phenomena, it is known as a reflection. Okay. Rays travel from one medium, strikes the surface, comes back to the same medium. Okay, right now I'm not moving on to that much technicalities, right? So this is the definition of the reflection given into the book. No, I'm not moving on to that much technicalities right now. Okay, I'm going to simply explain what actual the reflection is all about. Slowly we are going to be into the roots. Now, first we will move on to the reflection, then I'm going to explain its definition, then slowly I'm going to explain how many types of surfaces are involved into the reflection, how objects and images are formed, right? Okay, what is a virtual image, what is a real image, blah 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 blah. Okay, sometimes a virtual image acts like an object for the another mirror, and lots of things we are going to discuss, right? Okay. So, basically reflection phenomena related to light, which things are involved? Object, image, surface, medium. Things changes with respect to the medium, but soon we are going to reveal that. Okay, all are in mind. How it happens? Light comes from the one medium, it strikes the surface, moves back into the same medium. This is how phenomena moves on. Okay, now let's move on to the classification of the surfaces. Surfaces, right? See, suppose if I am going to discuss the surfaces that are only involved into the reflection, right, then I must say it will be wrong. If we are discussing it, we should discuss it once. Surfaces, right, involved in entire optics. Okay, because some students, while dealing with the sums, they are not even aware of what kind of the surfaces they are going to deal. Okay, the first one, right, is the plane mirror. This is the plane mirror, okay, separating the two media, or it is into only the single medium. Okay, this is the first surface that we are going to deal. The second is the concave mirror. Right. The third one that we are going to deal, okay, that is convex mirror. The fourth one that we are going to deal with, right, is concave lens. The fifth one that we are going to deal is, right, convex lens. These are biconvex, biconcave. Plano-concave, plano-convex. Right? The seventh surface we are going to deal with it, that is plano-convex lens. Right? This all are involved into the reflection. This all are involved into the refraction. Okay. After that, the eighth surface, right, that is slab. That is most we are going to use, right, for the refraction phenomena. Okay. After that, here comes, okay, the first one is a plane mirror, second is concave, convex mirror, biconcave, biconvex, plano-concave, plano-convex, slab. And after that, we are going to have concavo-concave, concavo-convex, concavo-concave, concavo-convex. But those will come up into the JEE examination or a JEE advance, right? Okay. So right now I am leaving that part. Okay. Right now I am leaving that part. Maximum in this entire chapter we are going to deal with this kind of the surfaces. Okay. In the entire chapter we are going to deal with this much kind of the surfaces. I am moving aside. If you want to just note this down, you can. Come on everyone. Then these are the classification of the surfaces. After that we are going to move forward, right, for the classifications of the what actual the object is, what actual the image is. Okay, that's it. You might have paused the video. Now, let's discuss about the object and mirror image using the plane mirror. Okay, what is an object? Okay, today's lecture will be totally a fundamental things. Okay, we are going to discuss those points that might create a myth into your mind while dealing with the ray optics. Okay, so doesn't means that, right, this is not important. It is important, but this lecture will make you fundamentally strong, right? Now, right now I'm taking the plane mirror as the reference. This is a plane mirror. Okay, the entity used for analyzing the phenomena is object. Right? Okay, entity that is used for analyzing the phenomena, it is known as object. Okay, this is the entity that has been used. It can be particle, it can be extended rod, right? Anything, it can be human, object can be anything, it can be particle, it can be anything, right? Okay, now how many types of images are formed within it? It is important to understand, right? Basically we are having the two types of the images. Okay, basically we are having the two types of the images. The first one, that is a real image. Okay, and second one, that is the virtual image. The first one, that is a real image. The second one, that is a virtual image. Now what is the real image? Real image, rays after reflection actually meets to form an real image. Right? Rays actually meet to form an real image. Okay, let's give the example here. Okay, first, how real image is formed and how virtual image, what thing we are considering as the virtual image, right? And what thing we are considering as the real image, right? Suppose here the plane mirror is there. The entity is kept at the infinite distance. Entity is kept at the infinite distance. Now what happens here, right? Okay, rays are coming on from large. Okay, I am taking the two rays. Rays are coming on from quite large, from infinite distance. Okay, after reflection, okay, see, rays are coming on from very large distance. Rays are coming on from very large distance, right? Okay, they actually meet at this point. Okay, rays actually meet at this point. Okay, so where rays actually meet, real image is formed. This is nothing else but the real image. Okay, where rays actually meet, the real image is formed. Now what about the virtual image? Where rays tends to meet. Or you can say rays, the simple word I can use, appears to meet. Right? Okay, let's take an example to understand this. Suppose if the object is kept at this position. Okay, now this kind of the reflection it is going on. See. Okay, see, rays after reflection move on. In the previous case, rays were coming on from the infinite distance and after reflection they were meeting at a single point. In this case, from a single source, rays are evolving, right? And after reflection, they are going back to the infinite distances. So, in this case, rays tends to meet behind the mirror. This is where the virtual image is formed. Okay. So, these are the two examples, right? How real image is formed, how virtual image is formed, and how reflection takes place. The first one is the concept of the real image. The second one, that is the concept of the virtual image. Now, from these two examples, you might be aware of how classifications works on, how reflection moves on. Today, we are only going to discuss about the how images are formed into the plane mirror, right? The combination of the two mirrors. Tomorrow, we are going to discuss the velocity and everything. Right? Tomorrow, we are going to discuss the velocity and everything. Right? So, if you have to just note this down, you can. Come on, everyone, those who are, okay. So, these are the two types of the images, okay. Now, you might have paused this video. The classification of the reflection, basically we are having the two kind of the classification. The classification of the reflection. What kind of the classification the reflection has? First, that is a regular reflection. Basically, it is a three. The regular, irregular, and the infused. But we are only going to deal with the regular and the irregular. The regular reflection and the irregular reflection. Regular, the surface is polished. This is a polished surface. Now, from the polished surface, what happens here? The beam is coming, the n number of the rays are coming, and they are parallel and equidistant with respect to each other. Okay. After reflection, it remains the same. Okay. The way they are coming before reflection, after reflecting, okay, the things are gonna remain same. This is nothing else but the regular reflection, right? In simply terms, if I want to define the way ray comes, the way ray comes, the same way ray goes. This is nothing else but the regular reflection. Okay. Now, if I'm talking about the irregular reflection, right? The second terms is irregular reflection. Irregular reflection always occurs right from the rough surface. Okay. Irregular reflection always occurs from the rough surface. Now, what kind of the rough surface? Let's check it out. Okay. Suppose this surface is rough. Okay. I must say sorry for that. Okay. This is a plane mirror, but it is a rough surface. It is kept for a years at some place, right? Okay. So, this is responsible for the irregular reflection. Light comes into the parallel and equidistant manner, but some goes here, some goes here, some goes here, right? Some goes here. This is nothing else but the irregular reflection. Okay. As because of the presence of the way light comes. Okay, is not the same light reflects. Okay. So, this is basically the regular and the irregular reflection. Now, we are moving forward to the concept of the plane mirror. How images are formed into the plane mirror. Right. Before moving on to that, let's have some, right. Let's have some things that we have seen. Okay, first of all, we started with the classification of the ray optics, reflection and the reflection. Then we moved on to the reflection. Okay, the surface is involved into the optics, the object and the image, the classification of the reflection. Now, let's move on to the, before moving on to the plane mirror, let's move on to the laws of reflection. What does the laws of, basically we are having only the two laws. Right, okay, two law. First, the angle at which the ray incidence is the same angle at which it reflects. This is the first law of reflection. Okay, suppose this is a plane mirror. Let's take an example to understand. Right. Okay, the angle at which ray is getting incident, that is known as incident angle. The angle at which, okay, ray strikes the surface, or in another sense, the angle that incident ray makes with respect to normal. Normal is nothing else but the perpendicular to the surface, reflecting surface. Okay, if I want to define the normal, normal is perpendicular to reflecting or refracting surface, right? The angle that incident rays makes with respect to, say, this is a normal, okay, this is the incident ray. The angle that incident ray makes with respect to normal, it is incident angle. The angle at which it reflects, right, it is reflection or angle of reflection. The first law states that theta I, that is equivalent to theta R if it is a case of the reflection, and the opposite side, okay, here the medium is not involved. Why? We are having only the one, right, a refractive index, we are having only the one medium, because the way the medium from which it travels into the same medium, it is going to come back. Okay, now if I am talking about the second law, the second law of the reflection states that, right, incident ray, reflected ray, and the normal all lies in a same plane, right? The incident ray, right, incident ray, normal, right, all lies, suppose this is the incident ray, this is a normal and the reflex, they all are lying into the same plane, right? This is the second law of the reflection. This is the incident angle, this is the angle of reflection, this is a reflected ray, right? Again, this is a normal. Okay, so these are the two laws. Okay, that is important, that was important to discuss, else some students are going to say again. Now we are moving forward to the plane mirror section, and it is important how, right, the images are formed into the plane mirror, right, how things are working on, how many number of images are formed, okay, what happens when the two mirrors are involved, how ray deviates through the two mirrors, lots of things we are going to discuss, right, lots of things we are going to discuss. Okay, now let's move on to the how images are formed into the plane mirror, the three most important points. Okay, first, how images are formed in plane mirror, what are the characteristics and the noteworthy points, right, okay, related to those of the images. Okay, let's move on. Okay, let's move on to the simulation. And yeah, this thing always makes me crazy. Okay, see, this is a flat mirror in front, this is an object, this is an image. Okay, virtual image is there. Why virtual image is there? Because the object is present, object is not at the infinite distance. In front of the plane mirror, if the object is at the infinite distance, then and then there is a possibility of the, right, a real image is there. Okay, the possibility of the real image formation in the plane mirror is only when the object is at the infinite distance. Right, now this is an object, this is a virtual image, the object and the virtual image. Now what happens here? Okay, simply if I want to define, right, the distance between the object and the mirror, this is a very common thing. Again, we are going to discuss into this some important terms also, but right now the distance between the object and this is a object distance, the distance between the image and the mirror, that is an, okay, image distance. But how the images are formed, right, it is important. See, images are always formed to three ways. The first, you can see, marginal, it means what? See, three options are there: marginal, principal and many. If I'm talking about, if you want to form the image, always cross the rays in three different ways. First, take on parallel to the principal axis. Second, take on through center of curvature. Third, pass on through focus. These are the three most important stuff through which we are able to identify how images are formed. But don't get worried, again the same thing we are going to see into the reflection. Okay, the same thing we are going to see into the reflection. Okay, now see how what are the characteristics. Suppose let us take an example here, right? This is a plane mirror. This is a ground. Okay, object is standing in front. Okay, this is the image. In front of the right plane mirror, in front of the plane mirror, the first most important point, image is same as of the object. I'm not talking about the dimensions right now, but image is same as of the object. Second, image is always uprighted. Third, inverted image is formed. Inverted image is like, suppose if I am taking up the the left hand into the image, again the right hand will up. If I am taking up the right hand into the image, left hand will move up, right? So this kind of the image that is at the form. Okay, the distance between the object and mirror will be equal to image and the mirror. Okay, distance between the object and the mirror. Suppose this is the U. This is the distance between the object and the mirror. U and V, they are going to be same. Okay, the distance between the object and the mirror and the distance between the image and the mirror are going to be same. Right. So these are the four noteworthy points for the how the images are formed, right, into front of the plane mirror. Tomorrow's lecture will be on entire this 4 points, and you will just imagine, right, how difficult sums we are going to see tomorrow. Immense content I'm going to deliver tomorrow, and that entire lecture will be on this 4 points. Okay, next. Suppose if two mirrors are kept, then how images are formed? It is important to understand now. Okay, if two mirrors are kept, okay, suppose let us take an example to understand it. Okay. Okay, now we are moving forward to the number of the images formed into the plane mirror. Okay, suppose this is the first mirror, right? Some students might be thinking, sir, you are going on into the quite a detailed manner. Bacha ji, right? Being a student, I have experienced lots of difficulties into the optics, right? So I am trying to cope up that. As of that reason, some students might be thinking, those who are watching this lecture, right, they might be thinking, lots of detailed discussion is going on. Beta, for the clarification, it is needed, because when you will move on to the reflection, na, right, all concepts will go to, like, they are going to mix it up, right, and at that moment, things are gonna you are going to lose everything, your confidence and everything, your fundamental concepts and everything you are going to lose. So for that clarification, right, at that moment, I'm going to save you all of that for that moment. So as of that reason, okay, I'm discussing into the detail. Now, suppose here the object is kept. Okay, I'm naming this as mirror 1, this as mirror 2. Right? Object is kept. See, okay, if I'm talking about mirror 1, the rays moves like this way. Right? Okay, the rays moves like this way. Now, okay, if the rays moves like this way, this is the first image formed. This is the first image formed, I1, the image of an object with respect to the mirror number 1. Image of an object with respect to the mirror number 1. See, if it is a two plane mirrors, right, the objectives are going to come on this basis, right, infinite images are formed. Right, I can understand n number of the images are formed, okay, but slowly we have to move on to the detail how the two mirrors are. Here two mirrors are in front. After this we are going to take an example in which the two mirrors are inclined and the images are formed. Okay, slowly we have to move on into the detailed manner, na? Else the things will get wrong. So this will be the first image with respect to mirror number 1. Now, with respect to mirror number 2, what happens here? I need blue. Okay. Behind mirror, they tends to move. This is image 1 with respect to mirror number 2. Image 1 with respect to mirror number 1. Image 2 with respect to the mirror number 2. Now, entire lecture it will be on the right plane mirror. Now what happens, right? Things are gonna get more weird. Please don't get worried. Now, whatever this virtual images are formed, right? Okay. Virtual images formed will act like a object for another mirror. Suppose here the first virtual image is formed. For M2, this will act like a virtual object. For this also we will get one image. Similarly, for suppose this is a virtual image with respect to the mirror number 2. Now this virtual image will act like an object for mirror number 1 and will form the another image on this side. I am going to trace each and every one. This is the tracing of an image. Okay. This is I1 and this is I of 2. Now, suppose, see, rays are moving like this way. Rays are moving like this way. Okay. Again, I am going to clarify. This is the first image, that is the virtual of an object. Object is in between. Right? Object is between. This is the first image with respect to each mirror images formed. This is the first image with respect to mirror number 1. This is the first image with respect to mirror number 2. Now, the first image that was with respect to mirror number 1 will act like a virtual object for mirror 2. This is virtual object for mirror number 2. Now see, from this rays are going on reflex. Rays are going on reflex. Okay. Again, for this virtual object, one new image is formed. This is image of 1 with respect to mirror number 2. Now, let's move on to the another. For the first step, this might be quite complex, but it is important to understand. Now, I am talking about the image. Okay, now this will act like a virtual object for this mirror. Ray incident, ray reflex. Okay, again, this is eye of image of 2 with respect to mirror number 1. First, for one object, 2 images were formed with respect to each mirror. Now, those 2 images act like a virtual object and again form 2 more images. First object was real. This is a real object that created 2 virtual images. Second step, 2 virtual images acted like a virtual object for the 2 different mirrors and created another 2 images. Now again, these 2 images are at some distance with respect to mirrors. They will again act like a virtual object. Okay, and here image will be formed I of some x. Here again one image is formed I of some m1. Like this way. This is how images are formed into the plane. It is important to understand. Okay, this is the way how images are formed into the plane. When the plane mirrors are kept in front, this is how images are kept. Now suppose plane mirrors are inclined. What happens? If plane mirrors are inclined, then what happens? Right? If plane mirrors are inclined, suppose these are the 2 plane mirrors that are inclined at some specific angle. Let's say this is mirror number 1 and this is mirror number 2. This is angle theta. Now, suppose if the object is kept somewhere here, right? If I'm talking about this theta, if 360 by theta is equivalent to even integer n, if you are dividing the first case, right? The first case, there are only 3 cases. Don't get worried. In some of the resources, the things are gonna get quite complex. Things are made quite complex. No, we are not moving on to that much part. Simple definition. If the object is kept in front of the 2 plane mirrors that are inclined at some see, this is the thing that are going to come up. This is how the questions are going to come up from the plane mirror section, right? I'm going to tell you all, don't get worried. Okay. So if 360 divided by theta is the plane, is the even integer, 360 divided by theta, that is nothing else but the even integer, right? Then number of images formed, that is n minus 1. Number of images formed is n minus 1. Yes or no? If you want to just note this down, you can. Come on, everyone. Okay. If the number of the images formed, right, okay, is n minus 1. The first case. Second, in second we are having the 2 cases. This is a plane mirror number 2. This is plane mirror number 1. Okay. Plane mirror M1 and plane mirror M2. Right. If 360 by theta is going to be the odd integer. Okay, or let us take another. First of all, you can just pause this video and note this down. Come on, everyone. You can just pause this video, right? Okay, and note this down. Okay. If 360 by theta degree is an odd integer, what happens here? If it is an odd integer, then we are having the two possibilities. What kind of the two possibilities? First, object is kept symmetric or not. If this angle is also alpha, this angle is alpha, then this is a symmetricity. The object is kept symmetric way in between with respect to two mirrors. Then n minus 1 will be number of images. The second possibility, if it is kept into the asymmetric manner, right? If it is kept with respect to the asymmetric manner, like this one is an angle alpha and this is a beta, right? Then n will be the number of images. Right? N will be the number of images. Okay. Now let's see some of the sums based on it. Okay. Otherwise, the students are going to. If two plane mirrors are inclined at the angle 60 degree, right, then what will be the number of the images? Just calculate 360 degree whole divided by 60 degree. It is going to be the even integer, right? So the value of the n is 6. So the number of the images will be 5 in this case. Number of the images in this case will be 5. Yes or no? Second one. Suppose object is somewhere kept here into the symmetric position. Okay, so here what is 360? If you just hold on, if you want to just note this. Okay, say for that. Suppose here the angle is keeping as 36, 36. The total angle between the two mirrors is 72. Now suppose if we are making it as 360 degree by 72, we are going to have the odd integer. Right? Okay, but here in odd integer we are having the symmetric angles on the both sides of the mirror. So here n minus 1 images will be formed. Okay, so it will be here the value will be 5 for n, right? So it is 5 minus 1, 4 images will be formed in this case, right? 4 images will be formed into this case. Now if I am talking about the third, right? Suppose same angle we are taking 40, 32, right? Asymmetric angles are there. So again, n it will be 360 degree by 72. That will be 5, right? So the number of images will be n. Okay, this is how things are gonna get work. If you want to just note this down, you can. Right? If you want to just note this down, come on everyone, you can. Okay, so this is how the number of the, right? Okay, this is how the number of the, I'm pausing up, right? If you want to just note this down, right? Now let's move on to the deviation of the light by the plane mirror. The sums from this are definitely going to come up into an examination. Deviation of light from plane mirror. Okay, only two cases are there. the first one, right? There is involvement of the first case, that is an involvement of the single surface. See, we are having only single surface. I am going to give you all the direct formula of it, and the sums basis on this are coming up into an examination, right? If the light is getting incident, this is normal, and this is getting reflected back. This is an incident angle, this is an angle of the reflection, right? It is angle of reflection. Okay, so what happens here? Okay, what happens here? See, simply by what angle light got deviated, the deviation of light, actually if the surface wouldn't present, this was the original path light followed. If the surface was not present, this was the original path the light was about to follow, but surface came up in between and light got deviated. So this was the deviation angle, right? Okay, so this deviation angle in case of the single surface, okay, it is defined as, right, 180 minus 2 of I. This is the deviation angle. Okay, in the case of the single surface, because into the, why I have defined this into the terms of the angle of incidence, because into the single surface only the angle of incidence is taken as the reference. The second one, when two mirrors are involved, suppose here the two mirrors are involved and the angle between the two mirrors is theta degree. Okay, light is coming on. Sorry. Light is coming on with respect to normal. Okay, it moves on like this way. Right? Okay. Light is coming from this. Okay, this is incident angle, this is a reflection. Again, this will be some angle and this is a angle, this is going to be same. Okay, light deviates from the path. Right, so in this case, the angle of the deviation delta, right, it is defined as 360 minus 2 of theta. Right. Okay, so these are the two direct formulas through which we can calculate this stuff. These are the three direct formulas through which we can calculate the sum, right? The two different formulas. Yes or no, guys? Yes or no? Okay. So what will be the path of deviation here? This will be the delta angle, right? Light was coming like this way and it was deviated to this path. Okay. Suppose I think let's take one example. Suppose if it's a single surface, an angle of the incident, it is taken as 30 degree. Okay, then at what right degree the light is going to get deviated? So it is 180 minus 2 of I. So theta, that is equal to 180 minus 60. Right, the angle of deviation will be 120 degree. Right. Second case, this is for the one surface, single surface. Suppose deviation angle is 180 degree for two surfaces. If the deviation angle is 180 degree, then what will be the angle between two mirrors? Again, deviation angle is equal to 360 minus 2 of theta, right? So 2 of theta, that is equal to 360 minus 180. Theta, it is going to be 90 degree. How we are going to plot the diagram for it, right? How we are going to plot the diagram? This is how we are going to plot the diagram. The angle between them will be 90 degree. Okay. The ray is coming. First time reflection. Okay. Second time reflection. See. Ray was coming like this way and it is moving like this way. So you can see now the angle of the deviation got 180 degree, na? Right? Angle of deviation got 180 degree. And see, this is a normal. Okay. This is the normal. This is the incident angle. This is a reflection. This is I2 and this is R2, like this way. Okay. So this is our the light got deviated from the two plane mirrors. Okay. I think that much is enough for today. Okay. Those who might have not seen this, you might have moved on, right, to this specific lecture. Okay. So guys, I think that much is enough for today. Let's keep this. I think it's time to go. Again, we are going to come back tomorrow. Tomorrow will be how the velocity of the images and objects are traced with respect to the plane mirror and everything we are going to discuss, right? Okay. So guys, tomorrow be present. It's time to go. This is I will be waiting for all of your feedbacks beneath the video. This is Indrajit Singh signing off from the desk, guys. Bye bye, Sat Sri Akal and Namaste from my side, Bacha ji. Bye everyone. Stay at home, stay safe, stay healthy amidst this pandemic. Bye, Bacha ji.